Good day and welcome to another edition of AEA Insight. My name is Daniel Odro. Today we bring you another interesting conversation. We are going to be talking about the story of the electrification of the northern part of Ghana and how that came into being. What the engineers had to do to extend power to the northern part of this country. It's an interesting story you would like to listen to, and you would have lessons to learn from it as well. Today, my guest is someone who's done a lot of engineering. And he says his name is Engineer Emeritus. So he knows engineering in and out. Jonathan Amoako-Baah is former Gradeco CEO, former VRA engineer, has played critical roles in the West African Power Pool, where he was seconded to oversee a lot of work in West Africa. So he knows a lot about the power and the energy sector, not just in Ghana, but in West Africa, the continent, and the world at large. Sir, thank you very much once again for your time. Today, we're going to be talking about a topic that is dear to a lot of engineers who have been a part of it. When they talk about the story of how electricity was transmitted or taken to the northern part of this country, it brings them so much joy. I remember when I spoke to Engineer Jabesh, he was also very excited about that story. So today, I'm going to be speaking to you about that story, how it began, and the processes that you guys went through as engineers to extend power to the northern part of Ghana. But first off, let's start with the accessibility of power in the whole of this country. Are we universal in terms of the access to electricity? Maybe from the time you were Gridco CEO. Do you know the percentage?
Currently, it's about 89%.
89%.
Yes. And I would say that we are quite doing well.
Okay.
And, you cannot have a full 100%. Any person who tells you that you can have 100% is joking, or it's not telling you the whole truth. Because even as you build, people also will be building new villages, will be coming up,
Okay,
who would need electricity. So until you can connect everybody, then, but I'm not sure that you can connect everybody. But then you have to connect as much as possible as you can.
Yeah.
So currently, as for the grid, it is everywhere. But then it is for the distribution to take it to the homes, to the factories, to the villages, and all. And that is where the problem lies.
Okay.
So, as I said, about 89%.
But comparably, in Africa, do you think we're doing well?
We are doing very, very well.
Okay.
In Africa. Because, not if you go to the Maghreb, Tunisia, Egypt, they are quite high in the 90s. Like maybe 95, 98%.
Yeah.
But then if you come to sub-Saharan Africa, I don't know why we call it sub-Saharan Africa, because Africa is Africa. If you come to sub-Saharan Africa, I believe that Ghana is stopping.
Oh, okay.
Yes. There's no country in sub-Saharan Africa that has built like we have. The accessibility. Okay. Yes, the accessibility rate or ratio.
Okay.
Ghana is about 89% as we speak.
Okay. Then we're doing well, even though the goal is to reach as high as possible, so that many Ghanaians can have access to electricity. Let's now focus on the northern project, how power was extended to the north. So in 1989, this happened in 1989, between 1987 to 89. What influenced the decision to say we have to take power to the northern part of this country? Is it population growth? Is it industrial growth? What was the motivation at the time?
The motivation was that a technical solution had been found. Power is a necessity, electricity. You can have it in order for you to grow, maybe economy. So it has to be everywhere. But then there are technical considerations that needs to be taken in place, For every electrical or power system, I mean, it's made up of 3 parts. We have the supply, which is the generation, the transmission, and then the load. Let me put it load, because the load is not only distribution. We have big factories like Valco, Steelworks, who take power directly. And you need to have a balance of the supply and the load. Otherwise, you are going to have a lot of problems. I mean, you may have Junso because you are not balancing very well. Because either the voltages will go high or low, and you cannot run the generators. The frequency will go high or low, depending on the supply and the load. So you need a proper balance, you know. At the time that Akosomo was built, the whole of Ghana load was about 100 megawatts, let me put it that way. And Akosomo was going to be built for 912 megawatts.
Really?
Yes.
9 times?
Yes, the whole of Ghana load.
Wow.
And most of them were concentrated in Accra, Tema. Maybe Takrady, Kumasi. And the rest were all households and not big factories to take the load. In the north, that one, it was nothing to write home about. So you need a technical consideration, then the economic consideration too.
Right.
So how are we going to, we are going to use so much to build. How are we going to recoup the money? So when Akosomo was built, they didn't build all 912. They built 588, and it was still big because 100.
Yes.
So they needed somebody to take a greater chunk of the load. That was why Abaco came in, to take a greater chunk of the load. And then also to help pay the debt that has been used in taking in building the dam, and then all the other facilities, the transmission lines. Now, that time it was Water River Authority. Mind you, there was no grid code then.
Right.
And even Water River Authority, when it was completed, we didn't even have transmissions. When I went to VRA, we had what you call the power operations. So it consists of the generation and then the transmission, one unit, until it got to a point that we had to separate transmission from generation because it was getting bigger. There were substations coming up, especially when we started to build the north. And then because the north, the load was so small, it was not possible to build the transmission line and then to energize it. Because there were a lot of problems associated with that. Long, lightly loaded, high voltage transmission lines. If you have those lines, the conductors by themselves, when you put 2 wires together, close by itself, they have what we call capacitance. The capacitance, I mean, if you have done some fixes, you understand what I'm talking about, you know. So, and this capacitance generates power by itself. And if you put a sending end, like where you are taking the power from, you have a certain voltage. Then where the power is going to, that is the receiving end. It has to arrive there at a certain level. Let's say if I'm sending 1,000 volts, at the other end, maybe it has to go to, let's say, 999. Let me put it that way, because some of the voltage will be lost. But because of the line length and the capacitance, it will generate voltage by itself. So it will let the voltage, instead of 999, maybe it will go to 1,050. Let me put it that way. It is what we call the Ferranti effect. And it will be very difficult to connect them to the load there, because the load is very low. But if you put the load there, if you have a bigger load, it would bring the voltage down. to the acceptable limit.
Okay.
But because you don't have that, you'll not be able to. Anytime that you try to energize the line, bam, it will go off. You understand?
Yeah.
You know. So voltage regulation will be very difficult. You need to have a lot of equipment to do that. So at that time, the technology has not been found to do that. To do that, you know. So that was 1965. So going on, and then in the early 80s, a solution had been found. The solution had been found. So if the solution had been found, why don't we take power to the north? That's still, for economic reasons,
Yeah.
it was very difficult because at the time that we did the project, the whole of the north, the voltage and the load from Techima, Sunyani, Tamale, Bolga, all, I mean, whenever you are going to do that, you have to do a load assessment to put the loads together. Then you aggregate them and find out how much load is there. It was at how much? Maybe 300 megawatts. That one, I said, that one was padded in order to make it look good.
Yeah, for economic
consideration. Otherwise. So we had to pad it, you know. And then we said, okay, but if we put all this load even together at once and we still energize the line, we'll not be able to do that because it's too low and the voltages will go high. And so we needed what we called shunt reactors, damming loads. They are loads, but not useful load. You understand?
Yes.
To help us be able to connect the towns and villages there, to be able to put the voltage there. So, as I said, the technology had come. Shunt reactors had been found, had come into operation elsewhere. So we said that, okay, then we need those things to be able to do that. So the team was put together. They did all the engineering studies and knowing how many shunt reactors that we would need, the transformers, the line. We took people to find the line route, you know, where the transmission line is going to pass to go all the way. There are people, there's a man in Akosomo. It's about 90 years now, some old man. I go to church with him. He was a surveyor and he walked the line route. Now it's easy. Maybe you can have a helicopter or a plane to pass and then it will plot it. But that day, you have to walk the line route, and they were using tripods like this.
So you started from where, Sunyani, or where?
From Akosombo.
Wow.
To walk the line route because they have to take the measurements. So it took a long time, and then to come and plot the line route and then the cadastre to find the hills that we need to climb, where there are, you know, river crossings and all those things.
Wow.
Yes.
That's a lot of work.
Indeed, it was. So they did all that. And then it was put to tender. And I would say the rest was history. Because then some contractors came to tender or bid, and then after going through, or we found those who were capable to build the transmission lines and the substations. And so that's how. But then the technical solution, as I told you, had to be found to overcome the Ferranti effect, that the high voltages that will be generated by using the shunt reactors, and then also the voltage regulation. It's all part of the voltage regulation to be able to get there.
But you mentioned that you had to do an assessment of the load, even at some point pad it for it to make economic sense. Did you have to justify why you had to go to the north and not another region, or all the other regions at the time had been given access except the north?
Yes. The transmission lines at that time followed a triangle. From Akosumo, you go to Tafo, to Nkoko, to Kumasi, then Kumasi descends to Obuasi. Those were the low centers, the mining centers, and the, you know. So after Kumasi, which is the topmost part, it doesn't go beyond that. You understand? So the rest were using some isolated diesel generator, some small generator to gas power the towns, maybe for limited times. 6 a.m. they bring the generator on. By 10 a.m. it is off. By 4 or 5 p.m. they bring it on. By 10 p.m. it is off, you know, because you have to buy diesel and put in, and it was expensive. But then we have Akosumo with water, and which was so. As I said, because when in 1965 it was difficult to send it, but then by 1985 the solution has been found, and everybody deserved it. As I said, electricity improves the lives of people.
Definitely.
So everybody deserved it. So why don't we send? But then, as I said, we'll do all the technical things. Initially, I said that it was not technically feasible. Now we find a technical solution. It's not economic feasible because the load is so small. When you build, the people cannot pay. But there is one consideration that overrides everything, whether technical, economic, or financial. That is the political. So maybe some politicians say that whether it is economically feasible or not, still send it. Then you have to do that. But then, as I said, when you have done the economic and the financial analysis, and because you want to send it, you would say that, oh, it is possible because we have done this and the returns are so much, the net present value is so and so, and everybody looks at it, oh, then. But sometimes you finish, you build, and then when you finish, and then you go and you put it on, and you see that all your calculations, your economic calculations. But then also, sometimes you go and you find out that the thing is not there. But immediately you put it, everybody is eager to have it.
That's true.
So then people will start citing industries, will start, those who don't have in their houses will start wiring and all those things. So, because they need to improve their economic life, their social life.
Of course.
Because, I mean, it's also a social amenity. Electricity is a social amenity. It's not only for, you know, because we need it in our homes to feel good. I can put on my television. I would drink ice water from my fridge. You know, so I would throw the thin pot bowl away. And then, you know, so everybody will be happy to have it. People who are not even ready, when they saw, when we were doing it, people thought that, oh, this is one of those gimmicks. But then when they saw that the thing was coming, really, then everybody, the euphoria, you know, everybody was, it's coming, it's coming, let me, you know, so.
But also, did you think about that if we got to the northern part, maybe because of our excess capacity, we could now transmit to our neighbors for some economic gains?
Definitely, it was all part of the game. As a matter of fact, I mean, when Akosumo was built, you know, the river Volta, it doesn't take its source from Ghana. It comes all the way, even some parts of it come all the way from even Mali and Niger, Burkina Faso, and all those things. So they also deserve some electricity. At any rate, when I told you, when Akosumo was built, it was only 500. Not only, it was 500. And so going on, but then it was designed for 912. Now it is 1,020 megawatts because we have improved the generation. So in 1969, there was the need to extend the electricity to Togo and Benin. So they had to expand the Akosombo plant. Although the distance were there, the generators were not, so they had to import the generators, come and install them to send it to 912 so that we can send it to Togo and Benin for economic. I mean, Ghana would earn some foreign money from that. So sending to the north, there was also the thinking that we can extend it to Burkina Faso,
Right.
which actually came off between 2014 and now. I mean, it was commissioned in 2018 when I was CEO of Gridco, when we had the power to Burkina Faso.
Oh.
And as we speak now, maybe Burkina Faso, they are taking about 150 megawatts, which is very, very huge,
Yeah.
you know. And the whole of the north also, they have gone up maybe about 800 megawatts. So between Techiman all the way to Burkina Faso, maybe about 1,000 megawatts. But then I told you that we had to pad it to 300 from the beginning.
Yeah.
But after 40 years, sort of, it's gone up, and it is still growing.
Wow.
Yeah, it is still growing.
Walk us through some of the challenges you had, or the technical assessment that you were doing, the economic, the financial, the political. What were some of the challenges, the team that was put together? What was the back and forth that you had to deal with to bring this to life?
There were a lot of challenges. I mean, we had overcome the technical challenge. I mean, the planning and all those things. But then physically, when we started the project, you have to go through uncharted places. I mean, thick bush, forest, this, and, you know, and there were also the weather challenge. I mean, you are building a line, you have to send a bulldozer to clear a path that you are going to, and it starts raining.
Yeah.
The bulldozer gets stuck. It's a very big challenge. You go through a land, maybe somebody's cocoa farm. Yeah, depriving the person of his economic, what is it called? Gain, let me put it, his economic sustenance.
Yes.
Because you are going to cut the cocoa tree, or mango orchard, or some, you know, you go to a place, sometimes people will come with guns. Yes.
Yeah, because that's their source of livelihood.
Their source of livelihood, you are depriving them of their source of livelihood.
There was no compensation for these people.
No compensation, you tell them that's compensation, but then you cannot go and just cut it and then not pay anything. You have to pay, but then maybe he expect that you come and pay him before you cut
it. Not after.
Know, after. But, you know, we have to know how much we have cut before we would also pay.
Yeah.
You know, so there were a lot of challenges. You go to a place, then they will tell you that, let's say the line is passing here. Then there's this tree, so we need to cut the tree. This is maybe not an economic tree. But you go and then somebody had put some white calico around it and say that this is my God.
Yeah.
So you cannot cut that tree. So you need to bypass it or reroute, which is not the original, you know. So it brought about a lot of challenges, like we needed to issue a lot of change orders in order to modify it. So some slight modification, because the contractor will tell you that you are giving me this. So if you say I should go like this, you have to pay. You know. So those were some of the challenges. And in diversions, you are going to increase the line length also.
Yes.
You know, so the characteristics that you have worked with are going to change. So sometimes even the equipment that you have ordered, you need to change them, and to all bring about increase in cost.
Right. Yes.
You see, so sometimes you do projects and they say that they are cost overruns. Yes, they are, but they are due to circumstances beyond your control that you need to do them. Sometimes also, maybe you haven't thought about sending the thing to some other place. The people will come agitating. If the thing is passing here, why don't you also? So there are this, they will go to their politicians, and then they'll have to come and, you know, do all sorts of negotiations, beggings, you know, to just to appeal to you to do something about. As I said, electricity is not only for economic, but it's also for social.
Yeah.
And people feel prestigious when they have electricity in their homes or in their cities, Because if I have electricity, it means that I'm a big city.
Yeah.
If you don't have, because there's city at the end of electricity. But if you don't have it, then they're a village.
Oh, yeah, that's a good one. There's city at the end of electricity. But if you don't have it, you have a,
In a village.
Well, that's true. That's true. So I mean, I so we are going to the north. We've done all the assessments and everything. The political will is there, and all of that. How long did it take um, in trying to achieve the objective that was set for the team? And first of all, how big was this team? How often did you frequent the northern region? Did you have to stay there till the end of the project, or you were just shuffling between Akosombo and the northern part? Walk us through that.
Okay, we set up a project team. So we had the office group and the people in the field. Okay. So we had the office and then the field.
So you were the office or the field?
I was in the office, but okay. I went to the field. Sure. I was in the office with Engineer Bisafa. He was our office engineer. When I watched his episode, he said he talked about being an office engineer. You know, it was a big thing. So he reported directly to the project manager or the director of engineering. So anything that comes to the project, any correspondence which comes to the project manager goes to him. And then he will find the appropriate place to. So me, I was working in the design and the project management and, you know, in that office. And then the people in the field are in the construction. So in the office, we will do all the approvals, what to be done. We send it to the field, and they will see to it that it is built according to what we have said it should be built. You know, so that was what. So the team in the office, the team, let me say, we had Jabish, we had myself, we had one of my mates called Okain, GST Okain. Then a younger man came, Ebenezer Kramwa. And then we had some Canadians helping us. One was Andy Parakoski. I was working directly with him. And then there was a Dave Freeman, but Dave was going to the field, but he had an office in Akuse. Our office was based in Akuse anyway. And then we're not the only people. We had some finance people who will be doing the financial things, and then one accountant. And we had a quantity surveyor to be doing all the quantities for us. And then the drivers. And then when we go to the field, we have the construction manager. That one was one engineer called Freddie. So Freddie became DC ENO of Vignari when Jabish left. Jabish was DC ENO. So when Jabish left, then Freddie took that position. And there was Enoch. Enoch was the equivalent of Jabish in the field. And then there were other people, Ricky. So in all, we were the
big team.
It was a very big team with the drivers. And then we had the younger people, the inspectors, the technicians. They were directly, on the site to see to it that we say that you have to use 2 bags of cement, 4 headpans of sand, so they were there checking the contractor. And then there are a lot of, let's say that they are doing a tower foundation or a foundation for the substation to have some equipment on it. And they put all the material, sand, in a mixer. So they have to time it. It has to take some length of time, let's say 30 minutes. So after 30 minutes, they have to pour the concrete. If it passes, let's say 1 second, it means that it hasn't passed there. So you have to reject it. Wow. Exactly, yes.
All right, engineer, so almost 40 years down the line since the electrification of the North, would you say this has transformed the lives of the people in the northern part of Ghana?
Indeed, it has. When I talk about the North, from the beginning, it's from Techiman, actually, all the way to Bolgatanga, Boku areas. When I got there, before the great Akusumo went to the North, and I go now, I see a vast difference. During those times, they were using isolated diesel generators, and it comes on in the morning, let's say 6 a.m. By 10 a.m. it is off. People go about their normal duties in the evening, let's say by 4 p.m. It comes on again by 10 p.m. It is off. So people didn't have the full complement of electricity to do whatever they wanted to do, the nightlife and all those things. But then with the coming of Akosomo to those places, you see that the people's life had improved. People have become sophisticated, as I said, and they are using a lot of gadgets in their homes, fridges. People are cooking using electric stoves. Industries have sprung up in the north. I mean, either there were some industries that were relying on their own generation. In some places, let's say the wood processing plants, they were using the shavings from whatever they have to generate electricity, which was not very economical. But then with the coming of Akosomo to them, they are now able to produce economically. And even people in the south here yearn to go to the north. In the past, if you ask people to go, what am I going to do there? I mean, there's no electricity, and now there's electricity, so they will go. And other people who hitherto were not even going to get it had gone to lobby for the electricity to come to their villages. And as I said, because there's electricity at the end, there's city at the end of electricity. When you have electricity, it means that you live in a city. If you don't have electricity, then you live in a village. So people's life have improved, and people are even yearning to go. Hitherto, people who will not go are yearning to go to the north.
All right. So do you see the northern part of Ghana eventually becoming a hub for energy exports to the Sahel region?
It has started already, Dan. I mean, if you go to Bolgatanga, there's a place that we built a substation called Nyanya. Nyanya has about 4 level sub voltages in the place. You have a 34.5, a 161,000, 225,000 volts, and then a 330,000 volts all coming there. And it is from there that we are taking the electricity to Burkina Faso at 225,000 volts. We're planning to take it to Bobo Dioulasso in southwestern Burkina Faso at 330, and then continue to Sikasso in Mali, and then finally to Bamako in Mali. We also know that since we have reached Ouagadougou, we can still continue from Ouagadougou to Mali, and then from Ouagadougou to Niamey in Niger, because Niamey is already connected to Nigeria, from Kano thereabout. So that we have a whole ring of, network from Nigeria all the way to, and then we have connected already to Cote d'Ivoire, and we built a 225,000 volts from Cote d'Ivoire to Liberia to Sierra Leone, and then all the way to Guinea. So we have all this. So the north would be, or Bolgatanga will be the center where electricity is taken from to the other regions in the Sahel area.
And finally, if you had the chance to do this project again, what would you do differently?
When we were building the project initially, the highest voltage in Ghana was 161,000 volts. Currently, our highest voltage is 330,000 volts. So if we had the chance to build again, I believe that we can even go to, let's say, 400,000 volts, because in some parts of Africa and even in Europe, they have even gone up to 750,000. And the higher you build the voltage, the more efficient the transmission becomes, because you can transmit greater power at higher voltages, less current, So your losses in the transmission system is going to reduce. You understand? So if we have the chance to do it again, or let's say that we are starting today, because the technology has been found, it doesn't matter at what voltage you are going to build, what high, extra high, or very, very high voltage you are going to build. The technology to overcome the high voltages at the receiving end has been found. In this case, by putting up the shunt reactors. Even we have some static equipment that we call static VAR compensators. They do the same thing, but they are not like the shunt reactors. They are very sophisticated ones, which can do the same work, but more efficiently than even the shunt reactors have been found. I mean, we have even put some in Tamale and Bogatanga. So we will be employing all those things to help us able to stabilize the voltages, to regulate the voltages very well, so that I wouldn't have the problem of this extra high voltages, which from the very beginning in 1965, because it was not available and we're not able to do that, we're not able to send power to the north. And many people made statements. I don't want to repeat those statements that because maybe the people didn't like you, they don't want to bring the power or something, but that was not the issue. We have to debunk that. It was a technical issue, which the solution at that time had not been found. And even if it had been found at that time, it was very expensive and costly to send the power there. But I think that it was the technical one, then the solution had not been found then. So that dictated when, because when the solution was found, everybody was happy, and quickly people were mobilized and the power was sent there. And it's been close to 40 years now. It's been close to 40 years. When the power was built in Akosomo, it took maybe 20 years, because 1965 up to 85 when the preparation started. But then after that, 40 years had elapsed since it was done.
Thank you very much for the pleasure of your company. Today has been another interesting edition of AEA Insight. Today, my guest has been Engineer Jonathan Amoako-Baah, is former CEO of the Ghana Great Company, Greatco, also a former engineer at the Volta River Authority. He has also worked with the West African Power Pool across the West African region, and he shared insights into the Northern Electrification Project and how that came into being. I hope you learned valuable lessons, and that's how we draw the curtain on today's edition. Until next time that we come your way, it's bye-bye for now.